we're going to start with quadratic roots. So what is a quadratic root? It is the place or the points at which the parabola crosses the x-axis or intersects the x-axis. So we're going to put the points at which the parabola intercepts the x-axis. Now, what it means to be a solution is that's the point where the y value equals 0, okay? Otherwise, besides being called a root, it can be called a 0 because it's where y is 0. It can be called just a solution. And it can also be called an x-intercept, which again, by definition, is where something intercepts the x-axis. When we're looking at the word roots, though, when we are dealing with quadratics, we are dealing with x squared. What is the opposite of squaring something? Taking the root, okay? We are finding the root of quadratics. That's why it's sometimes referred to as a root, okay? And so I will use those words interchangeably. I'll call it roots, I'll call it zeros, I'll call it x-intercepts, I'll call it solutions. I will call it whatever my brain decides to think of it, of those four. I think I usually say zeros most of the time, but you can call them any of those four things, okay? And when we refer to them as one of the four, we need to make sure we recognize what we're talking about. So what we're going to do today is we're going to look specifically at the graphs and what each of the types of solution looks like. So when we have two solutions, okay, that is where both sides of our parabola are going to touch the x-intercept. So that can happen if it looks like a smiley face. It can also happen if it looks like a frowny. Don't draw both, but you get the idea. It can be either. And on there, our solutions are where it crosses the x-axis. And it crosses twice, so that means we have two solutions. Okay, we can also have one solution. One solution only occurs when the vertex touches the x-axis. So anywhere where we draw it that the vertex would touch, that doesn't touch. Like that, like that, like that, whatever, okay? As long as just the vertex is touching, you are good. Okay, and the place where it touches, that would be your solution. That is no longer a function. That is a different type of parabola. So if it's shaped this way, okay, it's not the equation of x squared anymore. It's the equation of y squared. So it changes it, and it no longer is a function. Do y'all remember when we talked about what it takes to be a function, how it had to pass the vertical line test? Does that pass the vertical line test? No. It doesn't let it be a function anymore. And so typically when we're discussing quadratics, we are specifically looking at the form x squared, especially at lower level. Now, when we talk about no solution, that means none of the parabola touches the x-intercepts. I don't draw this, but I want to talk about it. If it looks like this, as it looks right there, that doesn't touch, right? But what would those arrows keep doing? They would keep going down, so eventually it would cross, right? So anytime it looks like if it's going towards the x-intercept, or the x-axis, it will touch it. So in order for it to not be able to touch it, it's going to have to be either above it, pointing up, or it could be below it, pointing down. Either way works. Either way would be no solution. And it's not just that it's no solution. It's that it's no real solution. And the reason I'm emphasizing that is in the second part of this unit, okay, we're going to be looking at something called imaginary numbers. Okay? There is a whole second number system dedicated to that. And we're going to start looking at it when we come back from spring break.
Is the new set of numbers going with no solution? Like you said, it's a new set of numbers for no solutions?
It goes to the imaginary numbers.
Oh.
Yes.
Can I read some?
I. 2I.
Another letter? Can I use your restroom?
Go ahead. Okay, but we will talk about that when it gets here. Okay. Now, we are going to do the same thing we've been doing for graphing and solving by graphing. We're going to use our calculators to make the table, draw the graph, find our solutions. So for number 1, okay, I'm no longer stressing about us finding the vertex and all of the different things, right? I'm no longer stressing about us doing all of that. I'm worried about us finding the solution. So when we start these problems, the only thing that I'm going to make you calculate is your axis of symmetry, okay? So when we do this, we need to do x is equal to, I do negative b over 2a, so it'll be negative 4 over 2a. So negative 4 over 2. What is negative 4 divided by 2? When we put that in the middle of our table, just like normal, okay, and plug it into our calculators, our calculator will give us what the y coordinate is when we calculate it. So when we go to our y equals on our calculator, and we type it in, I think is that the equation? And then do second graph. Okay, we find our axis of symmetry, negative 2. Okay, it tells us the y value next to it. What is that y value? Negative 9. Okay, so that is where what we can do to speed up this process. Because that's not my main focus, is us getting the axis of symmetry and the vertex. I'm not as worried about that now. I'm worried about us finding the solution. So you use your calculator to get the rest of them. When you plug in negative 3 to your calculator, what do you get out? Negative 2, or negative 4, what do you get? Negative 5, what do you get? Negative 1? 0? 1. So let's graph these points. So go to negative 5, 0. Negative 4, negative 5. Negative 3, negative 8. Negative 2, negative 9. Negative 1, negative 8. 0, negative 5, 1, 0. This one has 2 solutions. What are the 2 solutions?
Negative 5, 0, and
1, 0.
Where it crosses the x-axis, where our y is 0, that is considered our solutions. When we write our answers for these, we do not have to write the point as our answer, because by the name 0, or x-intercept, it's insinuating that y is 0. What we do to write the solution is we just say x is equal to, we use a squiggly bracket, and we write the set from negative 1 to 1. Okay, and another name for the squiggly brackets is braces. I'm going to keep calling it a squiggly bracket just because I like saying squiggly bracket, but you do, you boo.
No, that's right.
And so there's also a place to write it to the side, but I'm not really that worried about it. All right, now we're going to do the same thing with question 2. So for question 2, we're going to find our axis of symmetry. So we do x is equal to negative, what do I need to plug in for b? Over 2 times, which is going to equal, what does negative and a negative make? divided by, which equals. So in the middle of our table, we put a 1. Then I want y'all to use your calculator to get the table.
How long is your arm still? Sore from a shot?
Depends what the shot is. Like is it Tdap? That one kept my arm sore for a few days.
I'm at my blood tech and my 60-pound shots.
Your arm might be sore for a couple days. You'll be okay though. Did they do it in the same arm?
A shot in the same, and then blood in the same, and then another shot in the same.
I think there's a couple from that can hurt for a little bit. Yes. I thought you raised your hand for something. Happy birthday, by the way. I don't remember. I did tell you, didn't I? At least I'm not making everyone sing to you. I can if you want. Oh, okay. For -1, what's the y value?
4.
Wait, that was for what?
-1.
For -2, what's the y value?
9.
Positive 9 or negative 9?
Positive 9.
When I did it wrong, I'm getting 0.
Wait. Hold up.
I got 0.
For 1, what did you get?
4. Oh, for positive 1?
For positive 1, what'd you get?
Oh, I got 0.
For 0, we got
Negative 1 is just 4.
negative. Wait.
Yeah, negative 1. You want me to fill it out from the
I thought we put the numbers in the middle of the graph. Why are you starting up there?
I just went around them.
What is this guy?
I just put the numbers on there that would go around it. The middle is still there. I just put the others on it.
No.
9, 4, 1, 0, 1, 4, 9. There we go.
Yes, sir.
All right.
Dr. Man's
Yeah, go ahead. So we're going to graph this now. -2, 9. -1, 4. 0, 1. 1, 0. 2, 1. 3, 4. 5, or 4, 9.
I have a question. How do you see this? How are you like looking at this with these and figuring it out? These spaces are small.
They are.
Oh. Oh. That's why you're
I just got
Why don't you have them on?
I have contacts.
Oh, okay.
They haven't came in yet.
And what do you mean? The ones on y'all's paper may be small, but they're crisper than the ones on the screen.
Quit touching me, Keenan.
That is not me.
Yeah, I should know that.
Ethan has both of his hands on his desk, so it couldn't be him.
I was scratching my leg.
You such
Your
a
hand
liar.
was over here. I literally saw you move it real fast when he said, "Quit touching me, Keenan." All right. Where is our solution for this one? Where at?
Oh, 1.
At 1. So how many solutions is that? So we would do x is equal to. We still have to put it in the squiggly bracket. Because that represents a solution set. It is the set of solutions that makes that parabola.
So when you get your x equals, you always put it in the brace.
All right, now for 3. We're also going to do this one. So what is our axis of symmetry for this one? X equals negative. What is going to go there?
2.
Over 2 times. So we get -2 divided by -2, which equals, and that goes in the middle. Use your calculators to get the points on both sides. Friday before spring break.
put their phone number in. It says the host. She's. I wonder who this is. That's kind of like say him and text it later. Hey guys. It's kind of scary. What if it was Patrick? Probably Patrick.
I don't know who's that
Like,
using
how do they
who's
do
that
the
one.
H though?
Click the alpha button, and then the little green above the button, there's letters in green. And if you do alpha, you can do that. All right, for 1, what is the y value? For 1, it's. For 0, it's.
Something wrong with my calculator.
-3.
I can't get
Okay.
the same numbers for the Y value.
-3.
It's because you're plugging in a number. Okay, then what is the one for -1 and 3? For -2 and 4.
-11.
Okay, now obviously -11 doesn't fit on our graph. However, we can put all the other points. So we'll do -1, -6.
Miss Dawn, when you're done, can I see if you can fix my calculator?
Yeah. So Thomas, why are you convinced Emma's going to get suspended?
She hangs out with dumb, smart people.
All right. Now, that is our graph. Does it cross the x-axis? No, it does not. So we have no real solutions. And so we write our answer as the empty set. We either make it an empty solution set, or we can use the symbol meaning the empty set. Either works.
So when you try to get the graph right there, do you not plug in that equation right here? Oh, actually, I know what's wrong. It was negative.
Okay. Anne-Marie, were you plugging in a number instead of x? That's what does it. Because when you do that, it's only going to put in when that one number is there. Whereas when you do x, it plugs it in for every number. All right, now on the back page, we're going to look at the bottom half.
Somebody waste some water. I'm telling you.
Can I still go?
Do y'all need to go get paper towels to clean that up?
No, it is.
Okay.
No, this is the sound of the box.
Okay. All right, so we are going to talk about the discriminant. Okay, so the discriminant is actually a part of the quadratic formula, which we're going to learn later. But the discriminant can actually be used to determine how many solutions it has before we graph it, before we try to solve it, any of those things. So the discriminant can be used, or is used, to determine the number of solutions. Sure.
What's wrong with you?
Nothing. All right. So for the discriminant, it is D is equal to B squared minus 4 times A times C. So the discriminant, when it is bigger than 0, it causes you to have 2 solutions. When it is equal to 0, it causes you to have only 1. But if it is less than 0, that is when you have no real solutions. So we're going to go ahead and we're going to do number 7. For number 7, the first thing I want us to focus on is finding our A, B, and C. What is A? What is B? What is C? So to find the discriminant, we do b squared minus 4 times a times c. So if we solve that out, what is the discriminant equal to?
3.
9. Okay, and so is 9 greater than 0, equal to 0, or less than 0? Greater than 0. So that means we have how many solutions?
2.
All right, then we're going to go to number 8. So for number 8, what is our A?
1.
What is B?
-3.
What is C?
I'll do 10.
So to find our discriminant, what do we need to do first?
Square 3.
-3 squared minus 4 times. So what is this one? -31. And that is what? Greater than 0, less than 0, or equal to?
Less than 0.
Less than 0. So that means it has how many solutions? 0. Now we're going to look at number 9. Okay, so for number 9, when we get here, what is A? B? C. So to find the discriminant, we get what? -10. Where did y'all get -10 from? 10 squared. Okay, and what does that equal?
0.
So is that greater than 0, equal to 0, or less than 0?
Equal to 0.
Which means what?
1 solution.
Perfect. Let's also do number 10.
Check.
All right, for number 10, what is A?
2.
What is 4?
-4.
It is -4. What is C? -3. So when we plug this in, the discriminant is equal to?
2. I mean, no, wait. -4.
Squared
Squared, yeah. Plus.
times. Okay, so what does that equal?
I got 40.
So that's 16 plus 24. So yeah, that's 40. And so if you missed putting a negative sign inside parentheses, so if you messed this part right here up, okay, if you plug this into the calculator so that it's written like that, that will tell you the answer is -16. Is that what you get when you say -4 times -4? No. Okay, that is wrong. The calculator will give you the wrong answer if you type it in incorrectly. You have to put it in like this if you want it to give you +16. Okay, so if it gives you 40, how many solutions does that mean?
2.
Why?
Because
Because it's greater than 0. Okay, so what I want y'all to do with the last few minutes is I want you to do questions 4, 11, and 12.